Hello. So very good morning.
Today we will discuss about the a very good morning. Today we will discuss about the Maxwell equations. Previous class we have discussed what is a electromagnetic theory, particularly electricity and magnetism. We know very well what is a Ampere circuital law, Faraday's law of electromagnetic induction, Gauss law, and Biot-Savart law. Now we will discuss the Maxwell equation. Maxwell equation is a fundamental of electromagnetic theory. Now we will discuss the Maxwell derived the four equation based on the electricity and magnetism. Before that, we should learn some important equations. Now we will discuss about the some important vector result and theorems. The electromagnetism, we shall use the following vector results. Curl E equal to del E minus del square E. This concept will used in Maxwell's equation. Curl E equal to grade div E. Dot is a divergence and a cross product is a curl. Now we will discuss about the Gauss divergence theorem. Just revised already, we have discussed what is a Gauss divergence theorem and a Stokes theorem briefly. This is just a refreshment. There is a Gauss divergence theorem. The Gauss divergence theorem, it relates the volume integral of the divergence of a vector V to the surface integral of the vector itself. According to the Gauss divergence theorem, it is a closed surface S bound at any volume tau. Then this equation Gauss divergence theorem, that is a integration of tau divergence V into d tau equal to surface integral, closed surface integral V dot ds. That is called dot, meaning is a divergence, or integration of tau into del dot V. Del dot V is a div V d tau equal to surface integral of V dot ds. That is a volume integral is converted into the surface integral by using the Gauss divergence theorem. And another one is a very important Stokes theorem. The Stokes theorem relates that surface integral of the curl of vector to the line integral of the vector itself. According to the Stokes theorem, it is a closed path, denote the symbol C, bounds a surface S. Therefore, surface integral of curl V dot ds is equal to closed surface integral of V dot dl. Therefore, we will write this value curl V equal to del cross V. Curl is a vector product and divergence is a scalar product. Then curl V dot ds is equal to closed surface integral of V dot dl. Then the surface integral converted into the line integral. Very important, the Gauss divergence theorem converted volume integral to surface integral, that is a divergence V into d tau is equal to surface integral of V dot ds. The Stokes theorem, surface integral of curl V, that is a del cross V dot ds is equal to, and the closed surface integral line integral of closed line integral of V dot dl. The Maxwell's, the some fundamental of the Maxwell's equations. The Maxwell equations is a combine the fundamentals law of electricity and magnetism, or of profound importance analysis of the electromagnetic wave problems. Nowadays, the electromagnetic waves important role the modern technology, photonics, lasers, Wi-Fi, everything is a mobile phones. Everything is a based work based on the electromagnetic theory. The behavior of the electromagnetic theory. The behavior of the electromagnetic theory field is studied with the help of a set of equations given by Maxwell and hence called Maxwell equations. The Maxwell equation are the mathematical abstraction of the certain experimentally observed fact and their applications to all sorts of the problem in electromagnetism. Maxwell equation derived from Ampere's law, Faraday's law, Gauss law, and Biot-Savart law. The final equations listed. This is a, now we will discuss about the, we will prove the Maxwell's equation first law based on the Gauss divergence theorem, particularly that is a like div dot, this is a differential form equation, divergence D equal to rho or del dot D equal to rho. The integral form of this equation, the closed surface integral of D dot ds is equal to the volume integral of rho dv. This is a integral form of the Maxwell first equation. Second law is explained, derived based on the Biot-Savart law. The current density J equal to 0, therefore divergence of magnetic induction B also is 0, therefore integral form closed surface integral of B dot ds also 0. Third law, we will derive this equation based on the Faraday's law of electromagnetic induction. What is a Faraday law of the electromagnetic induction? First, we should learn some basics equations. What are the basic equations? You know very well. Ampere circuit law, Faraday's law of electromagnetic inductions, and Ampere circuit law. It is a basics is a very important. Before study this above equation, Maxwell equation, the student should learn the what is a what is a Faraday's law of electromagnetic induction, Ampere circuit law, Gauss law, and Biot-Savart law. This is a very important before learn these equations. Now we will discuss about, and also we will discuss about the fourth law is a Ampere circuit law. We are using the third law is a curl E, that is a cross product that we are using. Del dot is a divergent, there is a static charges, both electricity and magnetism. That is a Gauss divergence theorem is electrostatic field, and Biot-Savart law is a static charges, that is a magnetic field. Now the moving charged particles, we have discussed both electric and magnetic field. That is a curl H, both vector product we are using, that is a both direction and magnitude. The final values, that is a dou B by dou T is a partial derivative, and the integral form of this equation E dot dl is equal to minus closed surface integral of dou B by dou T into ds. We will prove this equation in Maxwell third. And fourth equation, that is Ampere circuit law. The Ampere circuit law we are using, that is a curl H is equal to sigma E plus dou D by dou T. This is a differential form of the Maxwell fourth equation. The curl E equal to minus dou B by dou T is a differential form of the Maxwell third equation. This all equation, that is a del dot D equal to rho, del dot B equal to 0, curl E is equal to minus dou B by dou T, curl H is equal to sigma E plus dou D by dou T. This is a differential form of Maxwell's equations. These are all integral form of the Maxwell equations. Now we should learn some basics. What is a capital D is a electric displacement vector, and rho is a density, volume charge density, and B is a magnetic induction, and E is a electric field intensity, and capital H is a that is a magnetic field intensity. Okay, now we are using here is a sigma E plus, that is a current density. Already you know we have discussed the previous class what is a total current density. That is the total current density can be classified into, that is one is a conduction current density, another one is a displacement current density in dielectric material. Okay, now we will discuss with the one by one. Maxwell first equation. The Maxwell first equation is derived based on the Gauss law. What is a Gauss law? You know very well. Generally, we are simply said Q is equal to the Gauss law. Generally, Generally, Q is equal to rho dV. Charge is a, V is a volume, and let us consider any closed surface. This is a any closed surface. This is a any closed surface. Now the charge is enclosed in the sphere. Now the charge is a Q. What is that? Density of the charge is a rho. Volume is a, we know very well, that is a V. Then we have discussed only small point, that is a dV. One point is considered. Therefore, Q is equal to total charge enclosed in the sphere. Therefore, Q is equal to total meanings we are using the integration part. That is equal to rho volume of the integral rho dV. The integral form of the Gauss law we know very well. Generally, we are using the Gauss law is equal to phi is equal to Q by epsilon naught. The Q value is phi is equal to, what is the Q value? Generally, you know very well, volume integral of rho dV by epsilon naught. Therefore, this equation, the constant, that is generally 1 by epsilon naught. That is a permittivity of the free space, that is equal to V into rho dV. This equation is explained in this part. Now, we know very well Gauss divergence theorem. According to the Gauss divergence theorem, before starting this chapter, okay, I explained what is a surface integral, closed surface integral. E dot ds equal to the surface, the Gauss divergence theorem change the surface integral to volume integral. E dot ds is equal to del dot E into dV, that is a volume integral. Now this equation substitute, this is a equation number 1, this is a equation number 2. Now we will substitute this E dot ds value, this is a equation number 3. Now the equation 3, substitute in equation 2. Now the equation, okay, substitute in equation 2. Therefore, E dot ds is equal to, that is a integration of closed surface integral of E dot ds is equal to, that is a volume integral of del dot E into dV, according to the Gauss divergence theorem used to surface integral to volume integral. The surface integral is a closed surface integral of E dot ds is equal to volume integral of del dot E into dV, according to the Gauss divergence theorem. See, now these values you know very well. That is a volume integral E dot ds. Before that, this equation E dot ds is equal to this value. First, therefore, del dot E. Therefore, substituting in this portion, this value, what is the value? 1 by epsilon naught into rho dV. Therefore, surface, that is a volume integral of del dot E vector into dV equal to 1 by epsilon naught rho dV. Now, this is a for true any volume, and the integral must be equal, cancelled each other. They must be equal. Or is it cancelled each other? We will get the del dot E equal to, that is a rho is available. Therefore, rho by epsilon naught. Now, divergence, that is a, you know very well, that is a del dot V meanings. We will write the del dot div V. Okay, basic. There here is a available del dot E. Therefore, we will write the div E vector. Therefore, we will write del divergence div E. Just don't put the dot. Whenever using the del is a mathematical notation, is a operator. That is a nabla. That is a del is a Laplacian operator. Generally, we are using, that is a del is a notation, is a mathematical function. That is a del is a scalar only for the magnitude. Del cross is a curl. Okay, del dot meaning is a divergence, del cross meaning is a curl. Okay, now we will using the but electric displacement vector. What is electric displacement vector? We know very well, according that is a explained based on the last classes. That is a d is equal to epsilon naught E. Therefore, these values, therefore, this equation 5 multiply both sides epsilon naught. Therefore, here also is a epsilon naught. That is a equation epsilon naught E divided by here also epsilon naught. Epsilon is a cancel. Therefore, we will write the only the epsilon naught E rho by, that's a cancel. What happened? Only for here is a div E epsilon naught E. What is epsilon naught E? That is a D. Therefore, f div D equal to rho. Therefore, we will write the div D equal to, generally we know that is a del dot D. Okay, therefore, del dot D is equal to rho. This is a differential form of the Maxwell first equation. Divergence of D equal to rho, or del dot D equal to rho is a that is a Maxwell first equations. Now we will write the is integral form of equation. Generally, you know very well this is a equation. Yeah, these equations. Okay. Now this equations we will write. Now this equation number E dot ds is equal to, that is the integral form of equation, surface integral of closed E dot ds is equal to volume integral del dot E into dv. This equation that is equal to, we know very well this equation del dot E dv is equal to, we already, that is a del dot, that is a generally we are using, that is equal to rho dv. Therefore this equation that is equal to epsilon naught E dot ds, the epsilon naught E dot ds values, that is equal to del dot E into dv. That is epsilon naught E meaning is a d, that is equal to, that is a, this value is denoted the capital D, you know very well this part. Okay. Therefore, del into closed surface integral of d dot ds is equal to volume integral rho dv. This is a Maxwell third equation. Any doubt your side? Okay. Now we will discuss the Maxwell second equation. Is a Maxwell first equation explained based on the Gauss law. Now we will discuss the Maxwell second equations. According to the Biot-Savart law, the electromagnetism, you know very well, the magnetic induction any point due to the current element, generally you know very well that is a dB into mu naught by 4 pi ideal sine theta by r square. The Maxwell, that is a Biot-Savart law, is directly magnetic induction directly proportional to the sine theta, current and length. Small length is a dl and inversely proportional to the square of the distance between them. In vector notation, dB is equal to mu naught by 4 pi, that is a, you know very well, r vector divided by r. That is equal to mu naught by 4 pi r vector into r square. Another one is a r cube is available. Therefore, mu naught by 4 pi r square into r cube ideal sine theta. That is a perpendicular direction. Therefore, sine, okay, sine theta is equal to 1, that is equal to ideal into r. Therefore, this equation can be written as, therefore, mu naught by 4 pi r square. We will write this equation, that is a r square r cap by r, that is equal to ideal r cap by r square. Therefore, the total induction be mu naught I by 4 pi 1 by r square into or dl by r square into r cap. R cap is a unit vector. From the Biot-Savart law, generally you know very well, replacement current by the current density J. There, what is the current density? The current passed through per unit area is known as current density. Now, that is value substitute. Therefore, we will write this equation. We will write there is J equal to I by A. Therefore, J dot A equal to I and capital I is equal to DL. That is equal to J into A dot DL. Therefore, J into dV. A dot DL is equal to dV. This value substitute in this equation. This is a, okay, therefore mu naught by 4 pi into 1 by r square j dot r cap into dv. Taking the divergence both sides. That is a divergence meaning is a del. Del dot b here, del dot mu naught by 4 pi 1 by r square integration of 1 by r square j vector into r cap into dv. Therefore, this equation, that is a del, this is a, now there is no current. What happened? There is no current density. Okay, current is 0, their current density also is a 0. Let us consider. Therefore, there is no current density. What happened? There is no current, no magnetic field. Generally, higher state is a explained when a current passes through the solenoid, which is produced, magnetic field is produced. There is no current. Then how it is possible to produce the magnetic field? Therefore, del dot B equal to 0. This is a Maxwell's second in differential form of equation. And generally, we are using what is the integral form of equation? Gauss divergence theorem, that is equal to volume integral to surface integral. Last time we are using del dot E into dV is equal to surface integral of E dot ds. Generally we are using. Now we are using the surface, that is a volume integral of del dot B is equal to dV equal to, so closed surface integral of B dot ds, that is equal to 0. Why the B says del dot B is a 0, then everything is 0. This is a integral form of the Maxwell's equation, second equations. Now, Maxwell third equation. Maxwell third equation explained based on the Faraday's law of electromagnetic induction. What is electromagnetic induction? Change the flux with respect. What happened? The change the flux with respect to the time which is produced. EMF is produced. Let us consider the work done at charge moving through the distance dl. Therefore, work done on the charge distance moving E dot dl. This is a line integral. Therefore, induced EMF is equal to W. Therefore, W is equal to EMF is equal to closed line the integral of E dot dl. The magnetic flux linked with the any closed area S due to the induction. Therefore, B is equal to phi. Phi is equal to B dot ds. Therefore, generally, you know very well this value, the phi value substitute in this here. Therefore, d by dt b dot ds. Very important. That is a minus. That is minus is very reason there. Don't be sick. So many students missing the problem. There's a mistake. This minus maybe will give the 0 mark. The minus of db by dt into ds. Therefore, closed integral of E dot dl is equal to minus surface integral of dB by dt into ds. This is a Maxwell third equation integral form. This now we're using the Stokes theorem. The Gauss theorem we are using only for the static charges. Stokes theorem using the moving charged particle. That is a Gauss divergence theorem is a volume integral to surface integral, but here is here the line integral to surface integral. Therefore, here is a line integral. Therefore, E dot dl is equal to curl E. Last time we are using the E dot ds. Now we are using the line integral. E dot dl is equal to surface integral of curl. That is a generally we are using the del dot E is a divergence E. But here is we are using the curl E, meaning is a this is a del cross E is a curl E. Don't put the in between the dot and here is a cross. Only we are using this symbol or this symbol. Now, that is a, we will substitute this value d dot dl is equal to curl E ds. That is integration of surface integral of curl E into ds. That is equal to the substituting the value. Therefore, minus of surface integral. This integral must be equal. Cancel to each other. ds and ds cancel. Therefore, curl E is equal to minus. This is a differential form. Now we will write this equation the partial derivative dou b by dou t. db by dt is a differential form and dou b by dou t is a partial derivative. This is a Maxwell equation differential form of the equation. Equation 1 and equation 2 is a first we derived the differential form, and equation 3 and equation 4 is a first derived the integral form. Next is a differential form. The Maxwell fourth equation according to the Ampere circuital law. The Ampere circuital law, what happened? That is a change the flux which is produced magnetic flux which is produced EMF is produced. Now what is here the B dot dl is equal to Ampere circuital law. The line integral of B dot dl is equal to mu naught I. Okay, when a current is passed through which is produced, magnetic field is a produced. Generally, we know very well there's a mu naught is a permeability, that is a B by H is a general. Generally, we are written this value mu is B is equal to generally we will write the B is equal to mu naught H. B is a magnetic induction, mu naught is a permeability of the free space, and H is a magnetic field intensity. This equations rearrange mu naught equal to B by H, or B is equal, yeah, this equation. Therefore, this is a H dot dl is equal to I. That is equal to integration of H dot d is equal to I. Generally, we know very well current equal to I is J dot ds. Therefore, correlate is equal to this. I value is a substitute here. Integration of line integration of H dot dl is equal to integration of surface integral of J dot ds. Now, this is a, what is a J is a current density. Generally, you know very well in dielectric material, current density can be classified. There is current density due to one is a displacement current, another one is a conduction current. The conduction current due to the conduction of the electron and a displacement current, that is equal to generally we are using there is a sigma is a conduction current density and dou d by dou t is a displacement current density. D is a displacement current density. Now this value substitute in this equation, that is a integration of L into H dot dl is equal to sigma E into ds plus dou d by dou t into ds. Generally we these values sigma s is equal to J1 plus J2 into ds. Generally you know J1 is equal to sigma E and J2 is equal to dou d by dot t is a derived. This is a in previous section. Okay, previous session we have discussed what is a current conduction current density and a displacement current density. This is a integral form of the Maxwell fourth equations. Now, what is a Stokes theorem? That is a line integral, then converted into the surface integral curl H into ds. Okay. Now, this equation that is a curl H into ds integration of surface integral of curl H into ds equal to sigma e what is a conduction current density, displacement current density. Therefore, integral must be equal, is a cancel each other. Curl H is equal to sigma e plus dou d by dou t. This is a Maxwell fourth equation in integral form. So any doubt? Thank you.